Welcome back, everybody. This is our third class in NEET previous year questions for chapter Electrostatic Potential and Capacitance, and this is a sub part of class 12th chapter Electrostatics. In this series, before this video, we have made two videos, and all of those videos are available on our YouTube channel. Again, name of channel is Point Basics, and there is a dedicated playlist for such type of videos. We have also started similar series for JEE previous year questions. So you can go to our channel and find those videos also. And all of these videos are listed in their dedicated playlist in our channel's playlist section. If you find these videos useful, then do press the like button, share them and subscribe them. And also, if you want to support us, then you can scan QR code in front of your screen and donate us with whatever amount you want or whatever is possible with. Any donation is helpful. So with this, let's start today's video, and we have covered up to question number 25th, I think, in previous video. This was the last question, and today we are going to cover the next one. So here 26. So two charges Q1 and Q2 are placed 30 centimeter apart. So we have Q1 here and Q2 here, and both are 30 centimeter apart. As shown in the figure, a third charge Q3 is moved along an arc of radius 40 centimeter from C to D. उसको C से D पे लेके आया गया. The change in potential energy of the system is given by this formula, where K is. So we have to find the value of K. So this question can be easily solved by using total energy. We just have to do what we do, that we will first calculate total energy at point C, and then we will calculate total energy at point D, and then we will take a difference of both of these energies. So let's calculate. Let me adjust pen's width slightly. So EC is the total energy of charge Q3 at point C. So in this energy, we will have two terms. First term from charge A, charge at A, and second term from charge at B. So from charge at A, it will be, oh sorry, K is already used, so we cannot use K. So it will be 1 by 4 pi epsilon naught into Q1, Q3. Q1 here produces the potential, and Q3 is in this potential, has some potential energy. So that is the potential energy divided by distance, that is 40 centimeter. Or we can say 40 into 10 raised to power minus 2. Now plus 1 by 4 pi epsilon naught. Now this there will also potential at point C due to charge at B, and due to this potential of charge P, there will be some energy of charge Q3 at point C. So for that, we have to find this distance BC. So this distance BC we can calculate easily using Pythagoras theorem, 40 square plus 30 square. That will give us 1600 plus 1900, 2500, and whose under root is 50. So let it make slightly more thinner. So new terms will be here, Q2, Q3 divided by 50, because it's in centimeters, so we convert it in meters. Now similarly for point D, total energy will be, now when Q3 is at point D, so its distance from Q1 remains the same, because that Q3 particle is moving in a circular arc. So radius of this circular arc remains the same, and as per mentioned, that radius is equal to AC, that is 40 centimeters. So AD will also be 40 centimeter. So here energy remains the same because distance remains the same, as energy is a scalar quantity. So Q1, Q3, 14 to 10 raised to power minus 2 plus, now for Q2, Q3, now their distance becomes to be 10 centimeter. Why? Because this distance is 30 and total distance is 40. So the remaining distance BD will be 10 centimeter. So now new distance between Q2 and Q3 is 10 centimeter. So these are the total both energy at both of the points EC and ED. Now what we take? We take difference of these to find out the change in potential energy. So final minus initial. This term is same in both, so it will get cancelled out. So we will have this term minus this term. Both of these terms, Q2, Q3 by 4 pi epsilon naught is common. So we will take them common, Q2, Q3 by 4 pi epsilon naught. And 10 raised to power minus 2 is also common. So we will be left with 1 by 10 minus 1 by 50. 50 will be the LCM. So here we will get 5, here we will get 1. So this will be Q2, Q3 divided by 4 epsilon naught. This will be 4 by 5 into 10 raised to power minus 1. And we can adjust it something like this, that this 10 goes above. So this will be Q2, Q3, 4 pi epsilon naught, 4 into 10 divided by 5. 10 get cancelled. So it will be Q2, Q3 by 4 pi epsilon naught into 8. Now we have to represent this into this form. So Q3 separate divided by 4 pi epsilon naught, and this will be 8 times Q2. So K is equal to 8 times Q2. Here is option C will be the right answer. Let's move ahead. Next question. Identical charges minus Q are placed at each corner of the cube of side B. Then the electrical potential energy of charge plus Q, which is placed at the center of the cube, will be. So we have to find out potential energy of a positive charge placed at the center of a cube whose cube's corner is occupied by negative Q charges. So let's first draw a cube. Suppose this is our cube. Now there is a charge, positive charge, at the center of the cube. Now what we have to find? We have to find, because at each corner there is a negative charge and positive charge is at center. So the distance of this positive charge from each corner will be equal. So we just have to calculate distance of this positive charge from one corner, and then we will able to find out the total potential energy of the system. Now let's suppose we give it some names: A, B, C, D, E, F. Okay, these will be the NF. Now let me draw a line connecting the diagonal from A to F. This line passes through the center, so also passes through the positive charge the positive also passes through a point where positive charge is placed. Now if we can calculate the value of AF, the diagonal AF, then we can divide it by 2 and then find out the value of this positive charge from any of these corner. Now to find the value of AF, we have to create a we can say right angle triangle, and for right angle triangle we have the hypotenuse. If we want to find the length of AF, then we will have to create a right angle triangle. For that, AF will act as a hypotenuse and FC, this FC side will act as a perpendicular. So we will need a base, and that base will be AC. So AC will act as a base, FC will act as a perpendicular, and AF will act as a hypotenuse. And this angle will be 90 degree. Now we know FC will be, because it is a cube of side B, so FC is equal to B. This FC side is equal to B. FC, BC and AB, all of these are equal to B because it is a cube. So B, B and B. And we know that each side of a cube is perpendicular to each other. So AB is perpendicular to BC. You might not get it in the diagram because we are drawing it on a 2D screen. But in case of a cube, AB is perpendicular to BC. So from using this scenario or this relation, in triangle ABC, we know AB is perpendicular to BC. So here AB will act as a, we can say, perpendicular, and BC will act as a base. So AC square will be equal to AB square plus BC square, and from this AC will be under root of B square plus B square, and that will be under root 2B. Now we have value of AC. Now we can find out in triangle AFC. Triangle AFC, we will have AF square is equal to AC square plus FC square. So here AF will be under root of AC square. AC square will be 2B square plus FC square will be B square. So AF will be equal to root 3B square or root 3 times B. Now suppose this is D. This point is O. Center point is O, and from center to any corner distance is equal to OF is equal to OA, because all distances are equal. So from diagram we can say that OF is equal to OA is equal to half of AF. So that will become root 3 times root 3 2 by of B. So we have a distance. Now we know that each of the charges are negative and potential is a scalar quantity. So direction does not matter. So total potential energy at point O. Total energy at point O. There will be 8 charges and there are 8 corners. A, B, C, D, 4 corners, and E, F, and 2 these unnamed corners. So total there will be 8 corners. So 8 charges. So what we do? We calculate energy for one and then we multiply it by 8. So we are calculating energy for this corner F. So here we have negative charge and here we have a positive charge. So potential will be produced by negative charge. So negative potential Q by 4 pi epsilon naught, and it is experienced by this positive charge Q and at a distance root 3 by 2 of B. So this 2 will go on the top and we will have something like this, minus 16 by root 3 and q square by 4 pi epsilon naught. Let's check. Okay, this they have cancelled the 4, so this will be minus 4 by root 3 q square by pi epsilon naught. Here minus 4 q square by root 3 pi epsilon naught, and also we forgot the b. So option C will be the correct answer. Moving to next question. In bringing an electron towards another electron, the electrostatic potential energy of the system will become. Now suppose this is our first electron, it has negative charge, so minus q, and this is our second electron, this also has a negative electron, and distance between them is represented by r. Now suppose this is stationary, so non-moving, because normally we take potential due to a stationary charge. So due to this stationary charge, potential at distance r will be potential at distance r will be minus q by 4 pi epsilon naught r. And now work done or energy acquired by this charge in the potential field of this charge will be is minus q times potential, so it will be q square divided by 4 pi epsilon naught r. Now if you see that this energy is inversely proportional to distance. If we decrease the distance, as per mentioned in the question, that we are moving this electron towards this stationary electron, so distance will decrease, energy will increase. Option B will be the right answer. Now moving to next question. A dipole is placed in an electric field as shown. In what direction it will move? So here we have electric field, and if we can see that according to the diagram, we can notice here that directions of electric field and direction of dipole. So let us draw the diagram. We know that direction of dipole is from negative to positive. So direction of dipole is something like this. This is the dipole direction, and direction of electric field is something like this. And also if we can see that these are electric fields lines, this arrow, and this arrow, these black arrows represent electric field lines, and they are diverging from each other. Their distance is increasing from each other. It does mean that electric field is not constant. This is the first point. And second, electric field is decreasing in x direction, or we can say positive x direction. As we are moving in positive x direction, value of electric field is decreasing because the space between electric field lines is decreasing. If space between electric field lines remains constant, then electric field is constant. If it increases, it means that value of electric field is decreasing, and if it is decreasing, space between electric field lines is decreasing, that means electric field is getting stronger. So now let's come to the potential energy of the dipole. So potential energy is given by minus p dot E in the vector form, and here we can see that angle between direction of the dipole and direction of field is 80 degree. So here we can say U is equal to minus PE cos 180, or U is equal to PE, where P and E are the magnitudes of both of these, dipole moment and electric field. So what we can say, it is positive energy of the dipole is, potential energy of the dipole is positive, and we know for any system to stable, for any system to be stable, potential energy has to be minimum. It either can be zero or negative if possible, and we know that potential energy can be negative, and it will be negative, or we can say the stable configuration will be when theta is equal to 0. In that scenario, potential energy will be minus Pe, which is currently positive Pe. So first case, to be in stable state, dipole has to rotate, but as per the options, there is nothing given regarding rotation. It is only given that whether it will move or it will stay. It will either it will move towards the left or towards the right, and it is also asked that what will happen when it will move either right or left. So again, I said that to be in stable configuration, potential energy has to be minimum, which can be either 0 or negative. So if dipole is not rotating here, then how it can reduce its potential energy? Then what we can do here, we can reduce value of electric field. As we know that electric field is not constant, it is decreasing in the right direction. So if value of E here, value of E decreases, so the potential energy as a whole also decreases. So what will happen here? Here dipole will move towards the right, and when dipole will move towards the right, then its potential energy will decrease. So option B, potential towards the right and potential energy will decrease, will be the right answer. Moving to next question. An electric dipole of dipole moment P is aligned parallel to uniform electric field E. Energy required to rotate it by 90 degrees. So initially we have given that theta is equal to 0 because they are parallel. So initial energy will be minus P E cos 0, and final energy, because we have to rotate it by 90 degrees, so theta final energy will be U2 here minus Pe cos of 90. So this will be minus Pe, and this will be, we know that cos 90 is 0. So change in energy, or we can say work done or energy required, will be final minus initial. So 0 minus Pe, that will be positive Pe. So option B will be the right answer. Moving to next question. An electric dipole of dipole moment P is lying along the uniform electric field E. Work done in rotating the dipole. So here it does not mention that up to how much we have to rotate it. So let's start. So initial angle, it is mentioned that dipole is lying along the electric field. So theta initial or initial angle we have 0. And suppose theta final is some value of theta which we don't know. We will try according to the whatever our answer matches. So initial energy will be minus Pe cos of 0, and final energy will be minus Pe cos of theta. So this will become minus Pe, and this will stay at as it is. So we can say work done will be U final minus U initial. So that will be minus Pe cos theta minus of minus Pe. So this will become minus Pe cos theta plus Pe, and from this we can take Pe common, and this will be 1 minus of cos theta. Now it is not mentioned here that how much angle we have to rotate it. Now suppose if we rotate by angle of if we rotate it by angle 90 degree, if theta is equal to 90 degree, so that will be our first case. In that scenario, cos theta will be 0 and answer will be Pe, because 1 minus 0 is 1. So 1 Pe into 1 will be Pe. Now second case, suppose here we rotate it by 45. In second case, theta is equal to 45. Then cos 45 is 1 by root 2, and in that scenario answer will be 1 minus 1 by root 2, which does not matches with any of the answer. Now let's take theta is equal to 30 degree. In case of 30 degree, cos 30 is root 3 by 2, and in that scenario answer will be PE 1 minus root 3 by 2, and that also does not matches. Now going to 4 option, that theta is equal to 60. Now cos 60 is half, so 1 minus half, that will be PE by 2. So PE 2 by is also possible, P is also possible. And there is one case also that theta is equal to 180 degree. Now cos 180 is minus 1. In that scenario energy will be 1 minus minus 1, so 2 PE. So depending upon angle, answer will change, and from all of whatever we have covered, it does not seem that option B will be a right answer. A, C, D can be right answer depending upon the whatever angle, because angle is not mentioned here. Some type of typo might be there. So let's move to next question. Electric dipole has a magnitude of charge Q and dipole moment is P. It is placed in uniform electric field E. If the dipole moment is along the direction of the field, the force on it and its potential energy respectively. So we have to find force and potential energy, and it is mentioned that dipole moment is along the direction of electric field. So theta is equal to 0. As theta is equal to 0, so we know energy will be minus PE cos of theta. So this will be minus PE, and we know this is the minimum energy possible for a dipole. So its energy, potential energy will be minimum. So here we can say minimum, minimum, and minimum, maximum. So D cancelled out, and also B option is cancelled out. So we have only A and C left with our answers. Now coming to the force, as mentioned that it is a constant electric field, and for a constant electric field, in a constant electric field, we know that the force is given by this relation, that force will be dipole times P into del vector of E, or if you want to we can say, if you want to write in a simpler expression, it will be something like that: Px curly x, Py curly y, Pz curly z of electric field. Now, so from this and you also have studied it in a simpler form, that if electric field is constant, then force on a dipole is also 0. And from this relation you can also find out that if electric field is not changing, E is constant, so all of the derivatives will be 0, and force will also be 0. So force is 0, and here energy is minimum. So option C will be the right answer. Let's move to next question. Some charge is being given to conductor, then its potential. So it is given to a conductor, so we have to tell about the potential, that what will happen to potential. So this question is slightly tricky one, because here answer will depend on the type, what type of surface or conductor you assume. Suppose first let's discuss case 1. What we consider as a hollow conductor, that we have some type of hollow conductor. It can be either a cylindrical hollow conductor or a spherical hollow conductor. Now in this scenario, we know that in case of a spherical hollow conductor, potential it's inside it is constant, and outside it is also equal to what is inside. So potential inside is equal to potential at surface is equal to 1 by 4 pi epsilon naught q by r. So in this scenario, we can say is same throughout the conductor for a hollow conductor. Now case 2, if we take a solid conductor like a solid sphere, solid conducting sphere. Now in this scenario, potential at center is maximum, and it keeps on decreasing when we comes out as we moves from the center towards its outer surface, and potential curves lies something like this. This is the potential at surface Vs. So actual potential lies something like this. This is the surface point or radius, and this value is equal to 1.5 of surface potential. So in that case, option B will be the right answer, that maximum at the center. But assuming if we case hollow conductor, it is we can say it is equal at every point. So maximum at surface, option A, and option C is same throughout the conductor. These two conditions satisfies. And option D is never going to satisfy, that it is maximum somewhere between. Somewhere between there is no maximum. So option D is wrong. And we can say option A is also wrong. And depending upon the type of surface we are choosing, it can be maximum at the center and same throughout the conductor. But normally in these type of conductors, what we assume, we also assume most of the time we assume hollow conductors. And in case of hollow conductor, it's same throughout the conductor can be a possible answer. Moving to next question. If a parallel plate capacitor connected to a battery are moved close to each other, then, so let's slide it slightly here. Now we have some options, and we have to find out that which of the option is right and which of the right option is wrong. So it is connected to battery, and we are moving plates towards each other. Now we know that for a capacitor, C is given by epsilon node A by D, where D is the distance between the plates. If we are decreasing the value of D, so C is increasing, so capacitance is increasing. So option 3 should be right. So option 3 is right, capacitance increases. And we have three, we have to find most appropriate. So option B will be wrong because 3 is not mentioned here, 0.3. And option D will also be wrong because also 3 is not mentioned here. Now 1 is mentioned in the both, 3 is mentioned in the both. So we have to mainly check second and fifth, but we will check all of these. Now coming to the charge stored in it. So charge Q is given by CV, and as C is increasing and potential is fixed because it is connected to a battery, and across a battery potential will remain constant, so charge will also increases. So charge stored in it increases, so option 1 is also right. Now energy stored in it decreases, so energy stored is given by half C V square. Here potential is constant and C is increasing, so energy stored is also increasing. So option 2 is wrong. And if option 2 is wrong, 2 is mentioned here, means option C is also wrong. So option A will be the right answer. Now product of charge and voltage increases, ratio of charge to its potential remains the same. So it is mentioned ratio of charge to potential. Now ratio of charge to potential will be given by charge by potential is equal to C. Q by V is equal to C, and we know as C is increasing, so this ratio is also increasing. So option 4 is wrong. And the product of charge and voltage increases. Now product of charge and voltage. So product of charge and voltage will be QV, and Q will be, we know that Q is equal to CV. Q is equal to CV into V. So it will be CV square, and we know CV square is double of potential energy. So it is double of potential energy, and we know potential energy is increasing. So this ratio is also, this product is also increasing. So option 5 is right one. So at last, option A is the right, will be the correct answer. Moving to next question. The electrostatic force between metal plates of an isolated parallel capacitance C having charge Q and area E, area A is proportional to. So we have to find out the force and what it is proportional to. So let's first slide it down and let's draw two plates. This is first plate and this is second plate. Now we are talking here about electrostatic force between plates. Note any point between these two. There is a slight difference between electrostatic force at some point between the plates and electrostatic force at a plate. And let me clear that what does it means. Suppose this is point A between the plates and there is a point B on the plate. So electric field at point A is given by sigma by epsilon naught, because this point has two contributions. Suppose this is positive plate, this is negative plates. So this point has contribution from positive plate also and negative plate also. For negative plate, electric field will be going towards it, and from positive plate, electric field will be going away from it. So at this point there will be two contribution for electric field. But at point B, as this point lies on this positive plate, so at this point its own electric field not be counted. Its own electric field will not be considered, and only electric field due to this negative plate will be considered. So electric field at point B will be sigma by 2 epsilon naught due to a single plate. So this is the difference between electric field at point B and electric field at point A. And as we are calculating only for the plates, so we will be taking for point B. Now force at point B will be, force is given by Q times electric field. So Q at this plate times electric field, that is sigma by 2 epsilon naught. Now again, this sigma is known as surface charge density for this negative plate, and this will be given by minus Q by its area, or we can say A. So this force will be, first of all, it will be negative force, means it will be attractive force by 2 epsilon naught A. Now, as per discussed in options, that we have to find that this force is either proportional to distance, 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 and distance. So we have to form this relation in the form of distance. And for that we can do that. We know that Q is equal to CV. So this will be minus C square V square divided by 2 epsilon naught A. And then we know that C is equal to epsilon naught A by D. So this will be minus epsilon naught square A square V square divided by 2 epsilon naught into A, and C is epsilon A by D. So epsilon square A square and also D square. So this get cancelled. This also get cancelled. We will be left with minus epsilon naught A V square by 2D square. Now let's check the variables. According to this relation, we have epsilon naught as constant, A is constant, and C is constant, and Q is constant. So Q is constant, C is constant, and A is constant. So epsilon node is constant, A is constant, and it is mentioned that it is isolated. Capacitor is isolated means it is not connected to any battery, and if it is not connected to any battery, in that case potential is also variable. So V is variable and D is variable, so we cannot form any relation something like this, that if we have two type of variables, what we can do here, we can as we know that Q is equal to CV, and here we can say uh, in this scenario Q is constant because it is disconnected from the battery, and C will not again be constant because we are moving the plates, and we are varying the distance. So what we will take this relation. Why? Here Q is constant as it is disconnected from the battery, epsilon node is always constant, and area is also constant. And from this, if we have disconnected it from the battery, this relation will hold, and according to this, force does not depend upon the distance between them. So option C, independent from the distance between the plates. And we can also modify this relation also, that we use V is equal to Q by C, and C is also variable, so Q by C is epsilon node A by D. So we use this here, minus epsilon node A V square, so it is Q square D square by 2D square as it is, and epsilon node square A square. So T square get cancelled, and this epsilon node term square get cancelled, and from this A get cancelled. So it again comes back to Q square by 2 epsilon node A. In these type of question, you have to keep in mind one thing, that you can only have one variable, and in this equation we does not have any variable, so it means force is constant. But if we put value of Q is equal to CV, in this equation C is also variable because distance is varying, so capacitance varies with distance, and potential is also variable because it is not connected to a battery. So these two are variables, and if we put value of C is equal to epsilon node A by D, again we will get V and D. Here both are variables, so we cannot conclude anything from these two equations. We either have one variable in equation, or we does not have any variable in equation, and in this equation we don't have any variation of force if Q is constant and area is constant, which is mentioned that it is an isolated, so charge is constant, so it is independent of the distance between the plates. So with this we finished this video here. Hopefully whatever we have covered here in this video is helpful to you in developing your understanding. Again, if you have any doubts or suggestion, you can put them in the comment section. I will try to answer them all. And if you like this video and find it useful, then do press the like button, share this video as much as possible, and subscribe to our channel. Also, if you can make some donations, then do please scan this QR codes and donate us whatever amount you want. Any small amount will also be helpful to keep this series ongoing on a regular basis. And with this, again, thank you for watching, and we will meet in next video.